Hello, welcome to this new module of the Osmosis course. In this lecture, you will be introduced to what a reference energy system is and how it can be designed. Here it is represented the overall structure of the following modules of this course. These lectures will be used to guide you through all the basic necessary steps to understand the elements of an energy system and how they can be represented in an osmosis model. Please keep in mind that along this training, we will take as objective the creation of a country model. Therefore, some information will be provided in relation to a country. However, there is no restriction to the definition of a model boundary in osmosis. During this lecture, you will be guided through the concept of a reference energy system and how it can be represented. You will then be introduced to the different approaches that can help in simplifying and aggregate different elements of a system in order to represent them in a model. Finally, you will be shown few examples of regional representation in osmosis. So, let's start now from defining what a reference energy system is. First of all, in order to represent such a complex system as the energy one into a model, it is important to find optimal ways to simplify the energy system up to a level that still allows to grasp the fundamental interactions between different elements of the system, without requiring too advanced computational tools to be able to solve them. Overall, the final goal is to be able to answer different policy questions that are driving the modeling effort. For this reason, as a starting point in our modeling activities, it is important to represent in a schematic and aggregated way what are the key elements of the energy system we want to model and how they are interconnected through the reference energy system, or RES. In doing so, it is fundamental to include also possible future technologies and interlinkages that are not there yet. In this way, the RES will show all possible present and future energy supply chains that can be linked to the provision of the final demand. The reference energy system will then be used as reference for building the related energy system model. Here we can better understand what do we refer to as energy supply chain and what are the main parts in a reference energy system. In the case of either an energy or an electricity system, we can define different so-called energy levels, named as primary, secondary, final energy levels. Each level entails different kinds of energy commodities or fuels, and it is linked to different technologies. Typically, the primary energy level includes all technologies and fuels that are related to raw energy resources, such as natural gas, coal, oil. In this level, typically, the primary fuels are imported or produced locally and made available to the system, to be further processed in the secondary level. The secondary energy level deals with all technologies that transform primary energy fuels into more refined commodities such as electricity and heat. The final energy level instead represents the transmission and distribution of secondary energy fuels to the demand side, where smaller appliances are used to convert the energy fuel into useful services for the final consumer. So, to summarize, a reference energy system we can say it is made of energy levels, primary, secondary, final, energy commodities or carriers, usually called fuels, such as oil, gas, biomass, electricity, and technologies, which either extract a primary resource or transform or convert one energy commodity in another, or transmit or distribute the energy commodity within the system, typically to the final demand. Here it is an example of how a reference energy system should look like. It is a common approach to identify technologies with rectangular boxes and energy carriers or fuels with lines, separating two different energy levels. In addition, the final demand is normally positioned at the far right end of the reference energy system, whereas the primary energy levels are normally drawn at the far left side of it, so that the energy flows from left to the right, down to the final demand to be satisfied.